I was muted, sorry. Boop, boop, boop. Okay, we're live. I know it's not 2 yet, but I am excited. I wanted to get started on this. Yeah, I need Windows. And everyone. Oh, I can have the game running. Python main. Yeah, we can have this going while everyone comes in and I post the socials. Copy that floppy. So I'm doing hashtag Python, hashtag Pygame breakout. Doing sound and score today. Yeah, and we're gonna slap that in there. Copy that. Post. Publish. Gonna exit. All right, now I need chat windows and we can get started. We'll pop out. Probably should have done that before the stream. Pop out. Twitch likes to put it down there, which I guess is fine. That's my main monitor. Not where anything is. All right. Look at those blocks go. Oh, why did I? Oh, yeah, that's right. Oh, that's fun. So like Owncast has this weird problem where, oh, that's what we need to add. Owncast has this weird problem where like you try to log into the admin session and like if your token's expired, it just says unauthorized. I think I've complained about this before, but it says that, oh, that's kind of cool. That probably shouldn't have happened exactly like that. Maybe we'll fix that during the polish phase, but sorry, not to get distracted. But yeah, so Owncast, when you log in to the admin panel, if your token, it normally just asks for your login credentials, and then if that's saved onto, I believe they're your cookies or whatever, then it will just reuse those credentials again. But if they expire, instead of like prompting you to enter the credentials again, it just says unauthorized, and then you have to like go into your browser's like cookies and like data. Like I had to do the Control-Shift-I and just go through like all like the cookies, the DB, like all the lists there, and just delete everything. So anyway, what made me think of that is that the chat window logged me out because I was logged in on my like Mastodon account for chat, like chat authentication, but that doesn't work, or that I deleted that data in order to log into the game, or not the game, in order to log into the admin panel on Owncast. Anyway, not important, just some actual tidbit of knowledge. Yeah, that was the other one that I was going to do. Probably not going to do it in that order. That's death. Game over. Got to be YouTube friendly. Me saying the word probably wasn't YouTube friendly, so hopefully I don't get demonetized. Not like I actually get money from this, but that might be a thing that I care about in the future. Hello. Hi. Welcome. Oh, yeah, I guess it's kind of weird. Anyway, so yeah, what we're doing today, still on Pygame. I think this might be the last day that I'm on Pygame. I want to move to Raylib and check that out a little bit. I've actually been reading more about that in my spare time and kind of getting some of that set up. So I'm kind of excited to do that. But today we're in Pygame and Python. I have a list of the to-do stuff over here. All of this. So in no particular order, I think we're gonna get sound first. What did I say? Sound, score, and polish. So yeah, we'll probably do sounds and then score. And then I want to do this today at least. And then if I have time, then we'll do player velocity and clamping the player movement probably in the same pass. And then we'll do game over as well. Maybe we'll do game over before player velocity stuff. But yeah, let's do sounds because I hope that'll be easy. Knock on wood. I almost did it, but I didn't want to like hurt anyone's ears. Where's sounds? Is it mixer? Oh, that's right. We have to do mixer and knit. Do I just want to do that up here? We do have a clock. Want to knit. Oh yeah, I initialized it, but Pygame mixer and knit. Oh, okay. So these are SDLs. Let's see, SDL2. You have the SDL2 base, and then is it under wiki? No. The GitHub. Okay, cool. So yeah, you have modules. The SDL font is just this. So these things are just wrappers against these. Well, not net. So this, and I think they've also exposed. Maybe they've exposed image and net. I'm not sure. I guess we just check image. Time music. I don't know why music and mixer are separate. That's fine. Yeah, it doesn't look like I have net, which is okay. Yeah, okay, so I think we're gonna do mixer and knit, and then we're gonna do sound. So here we're just gonna do a sound. Let me get that set up. I forgot where that was. Projects, bump. Yeah, that's what I played with. I'm not like a music person, so I just did LMMS, and there's like a little thing that there's like a little I guess instrument or synthesizer that is for like sound effects. So I just clicked on that, and there's like randomized buttons for different effects. Like you can make like a jump noise or a power up noise or like a hit noise or an alert noise and like a money noise and stuff like that. And so you just click on it and it does like random parameters to kind of sound similar to what those things would sound like in a game. So I just clicked that until it sounded good, and then I kind of messed with the knob a little bit because they give you a lot of tools to like change things. So so I did that. Whoops, that's not what I wanted. So yeah, I just made one of those with LMS. And that's the result of this. So I think we're just gonna load the sound file name. I kind of wish there was an example. Is it like relative? I mean, we can just figure it out. Okay, so we'll do bump, SFX. I guess we'll snake case. I particularly don't like snake case, but that seems to be what we would use in Python, I guess. That seems to be what other things use. So we'll just assume that it's local. So data bump.wave. And then I think we just call bump.play. So let's go down to here. Okay, and then we'll go up to the player specific collision. Oh, whoop. Okay, so 10 down. Yeah, there we go. Okay. Now I'm thinking with Vim motions. Oh. Bump is not defined. Oh, fuck. Okay. How do I do that? Is it a whole document S / bump, right? And we want to do bump. Well, I don't want that one. Okay, whatever. Bump, and then bump SFX. G, not G. That. Oh. Whole document S. Play. And I'm just gonna be play. Yeah. Cool. Yeah. Does it do the walls? Oh, okay. Yep, does the walls. Kind of annoying. But it's a sound effect. Probably find a better one online. I want to try and have it like happen multiple times. Oh, that's terrible. Oh, that was bad too. Ooh. Oh, that was too much. Dang it. Oh, did I get it? Ooh, ooh. Okay, yeah. Yeah, not bad. Okay. It was decent. The sound effect kind of sucks, but maybe I should do some music. Do some music. Oop. Oh, is that in the music? Mixer music load. You get like a music object. Oh. Okay. Oh, let me just call. Let's see. Do I have any music? I guess I have. I have VLC. Oh, it's just music. Okay. Or yeah. We'll do chiptune. That seems feels like winning. Sure. Copy that. Whoops. Python breakout data wave file. Oofda. Let's see what this does. Mixer, music, load. We're gonna load the file name, which is data. Copy. Whoops, shit. Loops. Oh, what are loops? Loops is the optional integer 0 by default. Indicates how many times to repeat the music. The music repeats. Definitely if this argument is set to -1, which I want. Yeah. That's very loud. That is overpowering, holy shit. Volume. Volume. Set volume. 0 and 1. Okay. We're gonna do like 7.5 to start. Still really loud. Still really loud. 2.5. I don't think this was intended to be a background. I mean, that's fine. That really gets the juices flowing, right? He says as he's yelling over the sound in his ears. All right, well, we got sound. Ooh, there we go. That was pretty good. Okay, that wasn't crazy bad. I was worried that the sound effect would be like when it happened like really fast in like the same frame or in like repeated frames, that it would sound like absolutely horrendous. But I don't think it was terrible. Okay, cool. So let's see, we got sounds. Easy peasy. Okay, and then I'm gonna keep score right now, and then we'll try to do the font to do it. I don't have score, do I? No. Okay, cool. Score equals 0, and then award amount equals 5. All right, and then so we're gonna go down. Okay, and then here we're going to increment score by award amount, yep, times y plus award amount. Yeah. So what that's gonna do is, let's get Milton up. So we have, I don't want to draw these out, they'll just be dashes right now. So these are going to be worth whatever the award amount is, right? These are going to be worth 2 times the award amount, and these are going to be 3 and then 4. So it's going to be 5, 10, 15, 20. And we get that because, oh shit, did I invert that? I think this is 0. Uh-oh. Uh-oh. Well, we'll see what it is. I'm just going to output it to the console because fonts are tricky right now. Maybe I should just do the font stuff. Okay, I'm gonna do console real quick. Score. Let me get that intersect stuff out. We don't need that anymore. Let's see, 9 down. I assume it's 9 down again. Perfect. Third, yeah, okay. So that's wrong. Okay. Because right now it's 5, 10, 15, 20, 25, 30. I didn't see what order they got those, but yeah, so okay, so that's wrong. How would I fix that? So I think I'm going to change how I spawn them. Instead of going top down, I'm going to go bottom up. So I'm going to invert the colors, keep the score the same, and then we're going to spawn them going the bottom and then coming back up. So we're going to start, so like index 0 is not going to be that red one in the upper left. Index 0 is going to be the bottom purple one in the left. Yeah, we're still going to grow. I think we're still going to grow left to right and then down up. Okay, and then I think we need to invert these colors because that, yeah, that'll be, so we need to swap that out and swap that out. Oh yeah, okay, so we just swap all of them. So let's see, I can do, okay, so this isn't going to be too bad. So what do we end with? Y is 6. So 25 times 50. No. 50 times 6. It's 3,300. Okay, and then we start at 300, 325. Why am I having so much trouble here? All right, I'm just gonna do, I think, we still don't want that 25. So 300 plus 25. Is that where we start? I think that's where we start. That's either where we start or we have to take into account the thickness of the block. So we either want 325 is where we start and we go down 50 more. So 375 is like where the bottom lip is going to be. Ooh, you know what? Shoot, here, let me, not that it really matters. Does this work? Okay, hold on. How do I screenshot? Yeah, there we go. Okay, so we need that. I probably froze the stream, I'm sorry. So now we're gonna go 325 and we'll make sure that this is correct. Okay, not correct, but because I didn't do this part, so we're gonna subtract instead of keep going. And then, all right, perfect. Yeah, that looks the same. It looks the same in terms of position. Jesus, so loud. Gonna go up here, maybe 15, maybe 10. Don't need that. All right, so that's good. Now we're gonna do word PNP. Oops. P. Delete word. PNP. P. Okay, colors are fine. So now this should give me 5. Yep. Okay, cool. And I don't actually have to play because we haven't implemented death yet. I think that's better. I don't know. I think that sounds fine, but like I'm also like listening to music on the desktop, and like when I'm programming, I'm not in that immersive. Yeah, okay. I'm not in that immersive. I was doing math game experience, you know. So I don't know, maybe the louder would have been better. So good at this game. All right, let's do font. Nice. So I loaded font up here the other day because I was going to use it for, I think, frame rate, because I was worried about our physics. So let's revisit that. We did font init. And true if the font modular isn't initialized. Get default font. Okay, so we can just get default font. Nope, that's not the thing we wanted. Oh. Okay, so that just gives us a string, and then we still have to load the font. Create a font object from the system fonts. Oh, okay. Create a new font object. Okay, and then get default font, get the file name of the default font. The file name of the system font. This is not the full path to the file. This file can usually be found in the same directory as the font module, but it can also be bundled in separate archives. In terms of this, the fonts available in the system, the names of the font will be set to lowercase with all spaces, punctuation removed. Most systems, but turn empty. Load the new file with a given file name of the size and height of font pixels. File name is none. The Pygame default font will be loaded. If a font cannot be loaded from the arguments given, an exception will be raised. If the font is created, the size cannot be changed. Font size 12 is used. Okay, so this seems like it's doing something similar to what I would be doing that I think I described a while ago. Okay, so let's just make this is font, and let's see, pygame.font.big font, and then file path none, size we'll just do 14 because we're fancy, and then draw text onto a surface. Oh, that's right. That's why this was not great. Oh, and it just gives me a surface. It creates a new surface, specified text rendered on it. No way to directly on an existing surface. Instead, you must use font render to create an image surface of the text, then blit this image onto another surface. Okay. And then we're going to need another one. I assume the screen surface, we can just blit. Okay, draw one image onto another. So source, destination, area none, special flags, rect. Right, source surface onto this surface. Oh, I'm almost out of water. Okay, I'm gonna read this. The draw can be positioned with the dest argument. Wait, what? Dest argument can either be a pair of coordinates. That is not how I read that would work. I would assume this would be area. The area argument can be a pair of coordinates representing the position of the upper left corner of the blit or a rect. A rect with the upper left corner of the rectangle used as the position of the blit. The size of the destination rectangle does not affect the blit. But you just said to modify dest. Oh, is this like a class member? Hold on. Yeah, okay. Okay, I see. That's where I messed up. Okay, so that's where my thinking was incorrect. So this is a surface, right? So like after we're done with everything outside of the step, actually no, we can just, well, yeah, no, we'll go up here when we're drawing because we just want to draw everything on top. So just right before here, so font, so this font dot render, right? The text that we want, I wonder if I can do like one of these. I should just be oh, whoops, nope, wrong language. Score. Oh, I guess that's gonna lag, or that's gonna be a frame behind, I guess, which I don't know. Probably won't matter actually. What was I doing? Then we want screen dot blit, and so we're gonna do font. Oh, we should like need that, not font. It should be like font image. And I don't know how intensive this is gonna be. So let's, okay, so now this makes sense. Because I thought this was gonna be I thought this was more like a function that we called. I didn't realize that it was like a method part of a class. But like the thing that the actual destination of the surface is the object that you're calling this on. The source is the thing that you want to blit onto the object that you're calling this on, and then dest can be either a rect, or it can be either a pair of coordinates representing the upper left corner of the image in I assume in the object space and screen space in our case, and then we can make dest be the actual, if we want to transform the coordinates or whatever. I think we're just gonna use dest. So right now I just want to, I think we're just gonna, whoops, I'm not typing over there. I just want to see what 1010 looks like. That's not exactly where I want it, but we'll see. Yep, okay, file path is an invalid keyword. Oh, did I spell that wrong? Actually, we don't need the documentation. We can just look at the code. Whoops, that was the wrong button. Where is it? Oh, I was on it. Init self name. Yo, am I crazy? Not that. Font. This is font. Yeah, it says file path right here. Size. Oh. should I just change it to name? Maybe that was changed. Okay. We'll just don't name these then. Takes 3 arguments? Oh, oops. Oh, okay. Okay, okay. All right. Whoops. And afterwards, assume anti-alias is a Boolean. True. Color. This is font color. White. And then I think I want none. I think I want none. I think that's fine. Okay, oh wow, that's tiny. That is very, very small. All right, cool, well, that's there. That's really weird. That is an awkward 20. It's an awkward 35. Oh, that's too much. That was a lot. It was way more than what I wanted. Alright, 600 or 100 points. Probably make the player blocks smaller, like thinner. Probably slower, or the ball faster. Sorry, I'm trying to like get it above. Cool, well, let's make that font really big. Oh, I'm not gonna get that. Okay, we'll pretend I died. Whoops, that's not the one I wanted. Like 40? Okay, that's better. I want it on the right side, I don't know why. That could be a cool exercise. So what we're gonna do is we're gonna move these down. I think I'm just gonna make it 55. We'll see how that feels. And then I want it, oh, let's center it. Let's center the score. We can center the score. So the score is gonna be overlaid. It's not like an actual real bar. Like a HUD bar, I guess. It's still going to be in the valid like game area, but yeah. So let's do this to 5, but it's going to be centered. So oh, do we want to get? We could get hella fancy and kind of try to. Oh, we'd have to calculate. No, it gives us a rect, doesn't it? No, I think Screenplit gives us the rect surface. Oh, interesting. Text. Oh no, that's returns. I was reading the wrong thing. Okay, this gives us a rectangle, which isn't useful. I was kind of hoping this would give us a rectangle. Well, what else does? Maybe I can get width. Oh, I can. Okay. I assume this is pixels. Yep, in pixels. Okay, cool. So we have that information. So let's get half of the screen. So we'll do screen.getWidth divide by 2 plus font image get width divide by 2. No, minus. And that should center the text, whatever the text is. So I guess the font's gonna move as your score changes, which we'll see how it looks. Okay, first try. Oh my god. Yeah, so it moves a little bit. I mean, that's fine. I could format the string to be different, so it shows leading zeros on the left side. Can we get 100? Yeah, we're gonna get 100. Boom, boom, boom. Oh, look at that. Oh no! Okay, I mean, it got caught in my shit physics. Yeah, I really want to fix that. Hopefully I will have enough time today. So let's see, we did score. So hey, look at that. I think we should do game over and then block layout and then velocity stuff and then physics. Okay. So now that we have font, we can render like a game over. We want this. This is game over. No, on the Y. Because that's right. And this is bottom. Okay, so game over. Game over equals true. And then come up. We probably want to do a bunch of other stuff there too. And then game over is false. Not is stepping or is stepping in proc frame or not. Oh, I think we want and for all of that. And not game over. Right. Then should probably initialize game over. Okay, yeah, so that happens. And so now we need to reset everything. So score equals, oh, we need to reset the blocks. Score equals 0. What are the initial player positions? This one. Do I just copy this? Split. I think so. Maybe I should make a game over function. Probably should. I don't want to reassign though. We're going to do player update, and we're just going to give it this v and back yank p. Cool. And we're gonna do the same with the ball. P. Ball pose, not update. Update. Read to the end. Yank that. Paste that. We don't want this. Maybe we can make a sound effect. Yeah, we just don't want that anymore. Okay, so game over. Then has started false. Score 0, ball. Oh, we need to reinitialize the blocks. Okay, so def init blocks. And then let's see. Guess we don't have to do ball physics anymore, so delete 2 down. Yeah. And then we want to do blocks clear Python list data structures append extend remove clear all elements equivalent to del. Cool. So clear, and then init blocks. Oh, and then we want to call init blocks. Did I forget anything? Oh, okay. Yeah, a lot of things. What are you complaining about? Start. Cannot access local variable start x where it is not associated with a value. It's right here. It's not local. It's up here. I already defined it. It's global. Just use that. You're using y count and x count. Why can't you use line 40? Yeah, that's weird. It was not local. How do you make globals? I thought those were globals. Whoa. Globals. Global variable. Okay, I need to sit down. Oh, yeah. Yeah, so I declared it before I called it. Oh, is it because, okay, I think it's because it's used, or like it's compiled. The definition for this is, well, because here they define it, right? And then they declare it and they call it, right? So I wonder if like the order matters. I don't know. And I don't want to like, okay, so nope, never mind, that should work. Why do you think it's local? What if I told you that it isn't local? Can you just fucking do it? Local variable where is not associated. Well, I mean, are you gonna be able to access blocks? I don't think any of this is used outside of that function. So I mean, I guess it could be like plopped in here, right? Does that fix your problem? But blocks, wait, Y count is not, is this Y count? Oh no, something else is using it. 209. Oh yeah, that's right. Okay, well, I lied. I don't think I like this album. Hold on. It's too industrial. Oh yeah, this one had the super sick album cover though. Moonwalk slaps though. Alrighty. Might have to take a break. Throat hurts and I'm running out of water. Okay, so I don't know why it thinks that that's a local variable. Is it because I mess with it? Oh. Is it because I assign? That's so dumb. Is it just complaining about X? Oh my gosh, hold on. That would be so stupid. Nope. Associated with a value. Sorry, cannot access local variable start X where it is not associated with a value. Okay, so I guess that's not it. So that's good. That's less dumb. Did I spell it wrong? Start X. What is going on? Okay, we're just gonna Google the actual Python cannot access local variable. Test A. Global A using non-local modifier on it inside the def, but it doesn't seem to work. While the variable are scope based, this means one cannot access a value declared inside a function. You can access a variable declared outside a function. Okay, so it was because of the order. Okay, so if I go up here and I go if I do this, go up here, and then it works. Because it'll need blocks, right? No. What? What? How many start X's? Wait, did that say start X? Yeah, okay, start X. X. And then it's still unbound local. This would fail. Oh, he's saying that would fail. This would print 1. Okay. Oh yeah, that makes sense. This would fail 2. Oh, so I'm reassigning. You need to tell the interpreter to find variable A in the global space. Okay. So I think it is a combination of the order. Well, actually, hold on. Let me just undo what I did. Let me put that back where I had it. And then I will just say global start X. They just declared it like that, right? I don't have to assign it or anything. Okay, now start Y. So global start Y. Global. No, we're gonna let it. I don't know why the other two. Maybe because I was assigning it. Oh, that's goated. Oh no, turning into a zoomer. I think combos would be cool to implement. Just like how if you hit more than one block before you hit the player. Oh, then you get like an increased score. Or like subsequent. That was a lot. I was not expecting you to move that much. Yeah, so that would have been a ton of points. So like each Like the first one you hit is just the point value of the block. But if you haven't hit the player since, any additional block that you hit, you get like a 2 times multiplier. Scores increase by 2 times. Yeah, well, like, I don't want to do that because, like, it's global, so just, like, fucking use the global. It's fine. We don't have to be good practice. Oops. Okay, what was I testing? We should die. Everything's reset. Oh. Okay, I see why it's bad practice now. So where are those being used? Start X is not being used anywhere. What about start Y? What? I put them in here. Oh, because I was using X count. That's fine. No. Okay, so then we're just gonna loop 50. This is what I try to do, but I think I did it with all the variables, and some of the variables were being used outside of the function. This looks good. Bop. Okay, cool. We reset. Why? Oh, does... Oh, I can't start again though. Uh-oh. Maybe we should record. Maybe we should clear the score when we start, instead of, so people can like screenshot. This is gonna be the next esport. Breakout Extreme. So not there, and then space start. Cube Center got all fucked. Oh, that's just because... Oh, do we use that for rendering? Yeah, maybe I should... Well, that's just debug. We can get rid of that. Maybe I should move that outside. P. Oh, I probably wanted the other one. Ugh. Okay, so now, okay, everything's reset. Oh, I can't move though. I think I can move initially, right? So I can kind of position where the ball goes. Okay, that's fine. So we can... Oh, how do I do that? Oh, just set the ball velocity to 0. Okay, so we don't have to... So we can only... Oh, does that happen inside the loop too? Okay, well maybe this was... Oh yeah, it does. Shit. Okay, well, I started to say shit and shoot at the same time, and I was like, shoot. Speaking like a foreign language here. So yeah, we just set ball velocity. Ball velocity update 0, 0. Okay. Is that it? I'm gonna have to take a break. I'm not thinking clearly. And we'll reset score. Got that 5. Game over, reset. I can move again. And we reset to 0. Perfect. See, things go a lot smoothly once I'm not struggling with the physics. But I need to get better at that, because I don't want to be a gameplay programmer all of the time. Or rather, it'd be more beneficial if I can do physics, because with that knowledge I can do some cool things, maybe. Oh, that was weird. That was really weird. I wonder if that like was a corner case where like the BV, like a literal corner case where like the BV like went through, like I don't even think I can draw this correctly. The ball like went like this, and it technically didn't hit this, it hit this. Or the order that we checked mattered. Actually, that's probably it. The order that was checked mattered, because I think we do top, then we do right, then we do bottom, then we do left, and since left was the last one and we don't early out of that function, then we just use left. Interesting. Okay. So since we're pretty far along, and I'm going to take a short little break after this, I think I was thinking that maybe I should just do a combination of that circle physics that we kept in here, and then checking. So do this, because then that would have taken the thickness into account, right? And so you don't get those dumb edge cases, and you don't get caught in a rectangle. Hopefully you won't get caught in a rectangle. And we'll just use, so like once we've detected like, oh hey, if we move here, then there's a collision. Then what we could do is we could undo that change, and then at the new ball center, or at the old last frame's ball center, draw a line from here and use that to draw a line between the centers, and that will find the intersection that we probably hit, because we run into a problem where if the ball is big and like the contact point is obviously like in here, we draw a line to here. Oh, I guess we could draw a line here. That actually might work too. That actually might be better. That might be a little better. And then I think we could early out, because we already know we have a collision, so we just want the first. I think you could also have problems. Because for this specific case that we just witnessed, it'll solve that, but I think you might have other problems too with the order of how we check things. But yeah, maybe this would be better. So we just, well, maybe not, because this point could also not be on the line, right? Or does it have to be at least on the line or within the line? I don't know. Maybe we can debug that. But I think that would be more solid physics, because I think this works really well in terms of collision detection, and like it's obviously not a tiny dot. So it takes the full volume into account. So I think it's way more accurate than what I've implemented. And then yeah, I think I can just do this. Something either there or there, I think would be fine. Remember, this is ball velocity, BV, and this is the center, which is a thick center. Let me tone that down a little bit. Be like, boop. All right, and then we kind of come from that, and kind of come from that, right? So BV. And so yeah, we would just construct a line here, and we would check that line to see if it hit anything. I don't know. I think this would definitely work. And I don't think there would be too many edge cases. Maybe there would be, maybe it would be edge case wise, it'd be better to do that. Because I'm afraid if like the ball is like hits the corner and like, I don't know. I guess yeah, whatever. Because if it's gonna be, if the position is in a way where the line hits this, then I think I can't prove this geometrically or algebraically, but I would imagine that would be the most accurate. It would be like, oh, you hit the left wall or the bottom wall. Okay, but let's game over. Oh, okay, we can do that. So I'm going to take a short break. I don't think I have to go to the bathroom yet, but I'm going to get some more water, walk a little bit, stand up, even though I was just standing up. Then we'll do blockout, layout, margin real quick, and then we will struggle with some more physics. Okay, let me put up Milton and do a little BRB. Wow. Okay. Okay, I'm back. That was very loud. Okay, sorry about that. So, no longer BRB'd. We are here. Oh no, someone joined while I was AFK. Shoot. Shoot. Sorry about that. But I'm back now, so don't worry. I guess to show who just joined, we got Breakout. Okay, they left. That's fine. Maybe I should just stop doing that because my own cast server might be bad. As in, it's like 20 seconds behind the actual stream. Might not get there in time. Okay. Combo? No, we're not getting the combo. Okay, well, since they left, not gonna show it off. Well, we'll show it off. There might be some other people. Oh, shoot. Okay, cool. Look at that, 35 score. Can you guys beat that? Probably. We're gonna do blockout margin. Okay, so I actually kind of needed to see. So I think I just need to calculate more gooder on the x-axis. So So yeah, starting X, I just kind of like guessed. So what I could do is do math to see where the start X was. So we would do, what would we do? We would do like X count times block size. Am I gonna get issues with those again? X count block size, right? And then see how many times that fits into screen width. Get width. Probably could have done that faster. Big A. So that gives me. What am I calculating? No, I think I wanna. I don't think I want that. I think I want. What was I thinking here? What was I thinking in here? I don't think that's what I want at all. I'm gonna delete that. Pop that there. And we want to subtract. Because I want the leftover space on the edges, and then I want to set the X to like half of what that is. So we have somewhat similar margins on the left and the right. So divide by 2. Okay, and then is it going to complain? No. Oh, do I need to do that again? Yeah, because I just set it to 50. Shit. Okay. I probably should have just like actually, not exactly what I wanted there. Probably should have actually checked to make sure it looked correct, which it did not. Okay, so what did I do? I don't think I'm taking into account the thickness. Why is that so different? Oh, yeah. I think I need to add. I think it's just calculating this rect right here. And then it's like based off of that. Because based off of that, I think that's very similar. He eyeballs authoritatively. I think that's kind of similar. So I think I either need to subtract block size. I don't know if it's full block size or half block size. Half block size. Oh, I didn't add that, but does that look? I think that looks good. I think that's what we want. No, let go in. Okay, there we go. That's not 100%. Okay, so I was right the first time, I think. I was just using the wrong value. Yeah, okay, I think that looks pretty good. And then yeah, obviously that should. Whoops, hey. Oh, dang it. Okay, yeah. Okay, cool. Yeah, that should have, well, that would have hit earlier, so that shouldn't have happened. Ooh, dang it. Oh! That would have been a big combo. If only I had implemented that. What have you guys done? Have you guys gotten 60 points in Blockout? Didn't think so. Okay, now, okay, we got an hour. We got a full hour to deal with this. I think thinking. I think it might be better to just not rewrite, but to do the enhancements to the physics system first. And then do player velocity, and then clamp movement to screen. Clamp movement to screen isn't too bad, because I don't have to do physics off of the wall or anything. I can just be like, are you outside the wall? Okay, don't move there. You are not moving this frame, or at least in that direction. What was I doing? Okay. Oh, I have to change my sheets, fuck. Okay, I just wanted to make sure that this worked. It looks like it do. Okay, so let's see. So do bounce physics. I wonder if I can change this. Who all uses this? Bounce. Oh, it's literally just these guys. Okay. I'm gonna reuse this, and I think I'm just always going to calculate the stuff that's needed for this. This is already doing the stuff, and it did collide, right? So this just needs to also return intersection 0, right? And that's going to be, does that just work, or do I have to define everything for the tuple? We gotta hit the wall. Tuple. Oh, okay, yeah, too many values to unpack, expected to. Yeah, okay, so we do need to capture all of that. Then also, I think we could also do the player stuff. Now we just stuff everything into this do bounce physics. And then through that, we can use all of that in both the circle velocity versus rectangle, right? And then I think that'll simplify a lot. So I want to line intersection versus the player. Oh shit. Well, we can still deal with that. So this can be moved later to something else, right? We can do sorry, I'm thinking. Here, you know what? I'm gonna go rogue, and I'm just gonna make new methods. So I think I still want this. What do I want to do? Do I want to refactor this? Or do I just want to make a new? I think I'm gonna make a new one. So we're gonna do def. Is that what I called the other one? No, we're gonna do collision. Okay, and then so do I just want this all in one thing, or do I want to like no, I think I want this to be something different. Rectangle bounce now. Sure, rec bounce physics. Yeah, sure, we'll do it like that. Okay, so at this point, the point that we're going to do here is we're going to reuse the do ball physics on each of the sides. So we've already determined that there is a collision using that other method up here. I don't know if we're going to use the point or not that's returned. That's okay. But we're going to basically do the bounce physics for the ball. So go back over here. I'm not sure what I need. So if we're doing it like I said up here, I think I just need the ball center and the center of the rect, or no, I need the rect structure. I think I expressed that, so I can do like ball center, and then I just need like the rect start, and the rect size. Yeah. And then I think that's largely expressed Oh, that's right. That's kind of fucky. Maybe... I think we're just going to leave this here. I was thinking maybe make these rectangles as well, but I don't think so. I think we're just going to do it like this, even though the ball technically clips into the what am I trying to say? The ball sphere, like, or the ball radius technically clips into the walls. I don't think that's too important. So with that out of the way, I think for this new one, I think I want to be able to express like a rectangle, like the actual data structure. And then I think we can make rect. Then I think that'll simplify a lot of things. Then, and yeah, I want to in that method that we just made, or that function that we just made, I want to reuse this, which we might not need intersection. Maybe we do. Maybe we can early out. And then I don't think, since we've already determined that we have a collision, we can do some of the, like, whatever we're colliding with outside of the function. We can decide if we're awarding points, or decide if we're going to do different things with I hope the player stuff. So the goal is to do all of this and like return the stuffs, and then outside of the method, I think we do this. Yeah, so we would just do, oh yeah, that's pretty simple. So I think in ball velocity reflect, yeah, so we can just return this diff normal, this diffter, right? So this I think can change. I don't think we need this. I'm gonna get rid of it for now. We can also do wall collision at that point, but I think this will do the calculations for that. I believe. Maybe it can't. Shit. Oh yeah, because it needs to center rect. Shit. We use the intersection. Fuck. We'll worry about that later. Maybe the player just has its own function again. We'll just worry about the common case for now. And then we will make it better later. So right now we're gonna do the bounce physics. So we have the ball center. What is the ball position, BV frame, ball velocity, start, end, and normal. Okay. You know, maybe I don't want to use this at all. Okay. Maybe we won't reuse this. Yeah, I mean, I guess, okay, so we need rect center. Yeah, we might not need a lot of stuff. Okay. So rect center, rect dot, then I need to do Pygame vector 2, right? And then we'll do rect dot x minus, I believe, half of rect. No, we want to add top left. It always trips me up. W, but still half. 5. Whoops. H, yeah. 0.5. Okay, that should give us the center of the rectangle, and we have the ball center. So we're going to make a line between that, which I guess is just ball center to rect center. And then we want to see if there's an intersection. Section. Oh. Is the whole point of this just to find the normal, though? Maybe I've been confusing what the point of this is. So I was hemming and hawing about how to do like all of this in one function. I think we use this to detect collision. Once we've detected the collision, we use the function that I'm currently writing to find the normal. And then I think after that, we pass in the normal that we found. Oh, I don't know what start and end mean. What do you mean by start and end? Get line intersection. Maybe we don't need to do this because we already did that. Okay, then maybe we just need to do this stuff and whatever happens next. So collision detection, we do the find the normal, and then either make this a function or copy and paste it for our particular use case. Yeah. Okay. That's a little more clear. Get line intersection. And then we are doing ball center to rect center. And then we need to, oh yeah, I'm gonna copy this. I don't want to do this again. Top right. Yank. Oh hey, I did like everything. Perfect. Okay. P. Right. Whoops. Left. Rect point. Oh shoot. Okay. Little dot. And then plus rect size. No. Oops. Width. Oh, place width. Word. Yeah, I think that's fine. What was that, point? Yeah, and then size is height. I think that's correct. Yeah, because top right is going to be rect plus width, and bottom left is going to be rect. Maybe I want to make all of these because now that they're not in vectors, I can't do that math stuff. Okay, so we'll do top left, which should be easy because that's just vector 2 rect.x and rect.y, and then we'll do bot. Wait, that shouldn't be left. No, yeah, no, that's correct. Bot right. Vector 2, and this is just added both plus rect.w and rect.y plus rect.h. Yeah, okay. And so here we're going to do a comment correctly. So we're going to test top line of the rectangle And remember, these aren't like axis aligned or anything. So I don't care about rotation. And then, so this is going to be the line. Top left and top right. Intersection 0. We want to return the normal Pygame.vector to, wait, is it a vector 2? Yeah, it's a vector 2, right? Yeah, vector 2. Okay. And the normal for the top is just a positive y. 0, 1. Okay, cool. Yeah, and then we just keep doing that. And what would you do? Your top right, and then bot right, bot right. Zero, return Pygame vector 2. And what direction is that going to be? It's going to be x. It's going to be positive x. Because our origin is like that. Where this is 0, 0. And this is width. Green width. Width. How do you spell width? This is height. I cannot draw with the mouse. That keeps going. Nothing in register. Is that what happens when I middle mouse click? Oh, that's cool. Okay, so now we're gonna copy this. So yank 3 down, paste that, and then let's see here. So now it's the bottom line. Oh, back. I don't think this matters. The direction of the line. So I was going counterclockwise, or clockwise rather. But I don't think that matters. And then this is going to be negative. That's wrong. Maybe it's not. -1. Why is that -1? Rect point plus rect size and then bot left. Yeah. Oh, because we want to. Yeah. Do an opposite of what? Yank 3 down. E. This is going to be left line. We might have to cut this short. We'll see. This is left, so we want bot left, and then top left. Okay, and then we're going to return 0, -1. Okay. All right. Do I just go balls to the walls and just start using this? I'm probably just start using this with the blocks first, and then handle special stuff, special cases with with the player. Oh no. Okay, so this is fine. Right, because how else are you going to express that? I think I do want it in a variable if it's not already. No, it is not. I think I have it at 10 right now. Let me update the drawing. Yeah. Oh, oops. Okay, yeah, that seems fine. Okay, and obviously nothing has changed. Hold on, I have to text the significant other. If I have to go, then I might end the stream and then come back. I don't know. For now, we're going to continue. So I think we have everything in place. We just now need to... That's the drawing code. We want this stuff. We might be able to change cue ball physics to not check for lines, because we have all of this information, right? So I might refactor this to serve our purposes for actual blocks and rectangles, and then this can just not do the line intersection, because we already know we are clearly not in bounds anymore. And maybe we can make this like less than equal to ball radius. And also this less than equal to ball radius. And then screen width minus ball radius. And screen height minus ball radius. That might make it look good. Okay. Right, hold on. Sorry, 1 second, everyone. Okay. So we want this after movement. Which I guess is right now. All right. Oh, you got that in front of the chat. Sorry. Hello. WSP. Absolutely. All right, can I show off? I can show off. So this is what we got. We got score, we got bounces, we got sounds. We got music, we got that. We can die, which kind of just resets the game. We got the music. Did I say music already? If you're not knowing, now you know. We can also die, which just resets everything. And our score doesn't reset until we start again, so you can screenshot it and tell all your friends how cool you are. Oh, that was so good. We're actually fixing that right now. You won't be able to wiggle between all of those like that, even though that's fun. Maybe I'll leave it in there, I don't know. Make the ball smaller and increase the gap size. That might be fun. I do want to implement the combos where if you hit multiple blocks before if the ball touches multiple blocks before it hits the player, then it increases the points that are awarded. Probably just doubles, so any subsequent point just gets doubled. And then whenever that resets whenever you hit the player again. Yeah. Yeah, fixing that too. So let's get back to the physics. So right now, did collide, which I'm pretty sure I have other places. Yeah, I have right there. Okay, so did collide, and then contact point, and then what did I name that? Circle versus rect. Yank. Yeah, what did that need? P. Oh, okay, that's fine. Well, that kind of sucks. Shit. Ugh. Okay. Ball position, and then ball radius. Do I change this? Well, I'm not using it anywhere except for right here, so yeah, let's just change it. So that rect, and then rect pose is fine. Rect pose. Rect size on that is W. Rect pose Y is fine. Y is fine, and this is height. Oh, and then I need to do more. Radius? Nope, I don't. Okay, perfect. Hopefully that still works. I think we're gonna draw stuff. And then, yeah, this just needs the rectangle, which is that. right? And then if we did collide, right, then we would get the normal from the new method that I just made. What did I call that? Rectangle bounce physics, which I'm not, no. We're gonna do, find collision normal, find face normal. Yeah. And that's gonna be find face normal. And that's gonna be ball position. Do I want to undo? Ooh, do I want to undo the movement at this point? Because that's what I was thinking. So we do definitely have a collision. So maybe we go back and then we find the normal. What does this find? Oh, this finds intersection. Okay, so maybe this turns back the intersection and the normal. Maybe. Oh, this is player. Yeah. So yeah, maybe this returns normal and the intersection point, and then we know we have a collision, so we have to hold on, I gotta text the girlfriend. Yeah, might need to end. We'll see. She's traveling today, so she might not have enough time to talk. But if she does, like I said, I might stop and we continue this later, or I continue later tonight. What does find face normal need? Direct. Okay, so that's B again. Okay, let's just debug this for now. I don't know how. I mean, I guess I could print normal, and then I think I used to draw the contact. I might have gotten rid of it though. Yeah, I think I did. Okay, well, we're gonna. No, we'll just draw it. Oh no, if did collide. Oh, oops. Okay. Oh shoot. No, that's do I just, yeah, I think we just stop. Oh, we can keep going. Oops. Okay, so we're just gonna break all collision right now as we debug. And then we're gonna do if did collide, then we're gonna do circle, screen, red, contact point. Yeah, just make it 2. Okay. Fuck. Okay. Oh. Shit. Where? What was wrong? Oh. Wait. Rect center vector. Where is that? 184? 184. Vector. Oh, all these are fucked. Just those two, just kidding. It's not a complete tragedy. We found the normal, so that's good. So this is the frame that we're doing the correction. So like it has already, we're drawing the uncorrected thing. So we still have to do that. So it won't be there, but like that movement was detected and the collision was detected. Now we're gonna write the stuff that like does the bouncing, puts it back to where it was, the position to where it was before it moved this frame, calculate the reflected vector off of the normal, which is why we got the normal, and then we're gonna like move the position over to here. So yeah, it'll look good, hopefully. I do kind of have to pee. And then I didn't see that. Oh, that's because I'm drawing this stuff. I thought that was the physics. Okay, so we're gonna get rid of that. I'm gonna draw it at the end, so it's not on top of anything. Okay. I wonder if I'm using did collide for other things. Using it up here. That shouldn't. I don't think. Maybe I'd make it a new thing. It's called DC. Okay. Losing my shit. Oh, I wonder if contact point is being overwritten. Because this is printing out, the normal is printing out, so we know at least at that point. Okay. Okay. Oh. What? Why is that not? Why is that like not persisting? That's outside of the running, right? This is during the rendering. What the fuck? Well, what's contact point? Because contact point could just be incorrect. Well, I'm also not getting that debug, so I don't know. Wow. Okay. What? There was a true, you saw it, right? Okay. So it is true. Just not persistently. All right, I have to take a little break. Gotta go to the bathroom. I'll come back and we will trudge on this physics endeavor. Didn't get water, that's fine. All right. Probably could have had the game running. Sometimes forget that the game is runnable. Okay. Okay, so we're gonna make contact point something different, or no, we're gonna make something different. Oh wait, no, I want to do up. Last contact point. Vector 2. And then I think we're just gonna unconditionally draw. And then if we had a contact, then we're going to do last contact point equals contact point. Okay. I don't know why that wasn't persisting. I think because it was global, I think it was getting intercepted by a different collision thing, and it was just getting reset, which is fine, whatever. Oh, I guess maybe I could fix that. Hold on. Well, no, because I changed it to DC, so I don't know. I have no idea. Okay, but that looks fine. That looks correct. Right, and I'm gonna. Okay, cool. And that looks like the correct thing already. Okay. So now we can move forward. So once we've done that and we've found the normal, we've already established that we have a collision. I think I'm just gonna do def do bounce 2. Well, do I want this to do, what do I want this to do though? I think I just want it to do that internal stuff. So what does this need? This needs ball position, frame, and ball velocity. I think that's it. And then we're going to calculate the leftover. Oh, we need the intersection point. Shit. The intersection of what? The line. Yeah. Okay, so that just turns into ball position plus B frame minus the intersect point, which I think I'll need. Leftover, then we're going to set the ball velocity to left. Ball velocity reflect on the normal. We need the normal. Ball position. Intersect point plus left over. I think that's it. I need the intersect point. So let's come down to here. We have the normal. I think find face normal. We also need to return the intersect point, which is 1. okay. Then we also have the, whoops. Right, and then here we're gonna position minus equals PV frame to give us the original thing, and then we need to calculate the corrected thing. So do bounce physics 2. We're gonna give ball pose BE frame ball velocity intersect point, and then our normal. And I might need to return like the ball position and the ball velocity out of this, but let's do like a little print. Ball pose going in, and then ball velocity, and then have it coming out. Oops, hit F9. Okay, so it didn't change. Nothing changed. Okay, so we just need to return, I guess, ball velocity. So it understands. Okay, probably because they're named the same. These are named the same as arguments. So the arguments are the same as the globals. So I think these are local versions, and it just kind of ignores the global space. So that's okay. We're going to return the ball position that we modified and the ball velocity that we have modified. And then down here, we're just, whoops, that's not what I wanted. Ball pause and ball velocity. Yeah. Okay, and they did change by step. Step. Look at that. That's beautiful. Oh, I didn't reflect it. Okay. Wait, no, I thought I did. Hold on. Yeah, no, we reflected it. Why was that not? What? Left over. Hold on, what was that? I wonder if I didn't push it out. I don't know why it thinks. Okay, here we go. Oh, weird. But the normal's the same. Oh, so it's just reflecting. Okay, so it's still stuck inside, so I need to push it out correctly. Wait, intersect point. Oh, I don't think I want that. So what is left over? The distance between... Oh, I think I'm calculating this incorrectly. So I want ball pose to be intersect point. I just want the distance. This should be a scalar that I should be multiplying. Maybe that's the real bug. Okay. Here, all right, getting a call. 1 second. Oh no, I lost my viewer. Sorry, significant other called. We haven't talked all day, so. But she is busy traveling, so we're gonna continue the stream. So let's see, what was I thinking about prior? We're gonna go over here. And so I wanted the magnitude of this. So do we have a magnitude? We do have a magnitude. Oh, magnitude squared. Is that... Okay, that's fine, sure. Okay, let's do magnitude. Oh, that was wrong. How do you spell magnitude? Oh. Wow, I was way off. Okay, so we're doing intersect point and leftover times ball velocity. So now, so before, I don't know what I was doing. I don't know why I thought this was good. But I was just taking, I was finding the, so once we found a collision, right? We had the intersect point and then we had the, whoops, we had the ball position, right? And then that's like, whoops, let's say we were like this or something. I don't know, something like that, right? And then so we're trying to move to here. This is where the ball was. Okay, that's kind of terrible. Maybe it's like this. And then like we're trying to move into here, right? So then we were taking this distance here, between here and here, right? This is a vector, which is from here, subtract here, which might not be the correct direction or anything. And then we were taking this intersection point and adding this, which like wasn't correct, right? Like I don't know where or why I think I took a break or something, because I remember saying that we needed to project this. We needed to do it like this, and for whatever reason that got lost in translation, and it ended up just being calculate this vector and then just add the intersection point with the leftover amount, which is not correct. We wanted the distance of oh, maybe magnitude isn't what I want. Is there a distance? Length? Oh, it's just length of self. Is magnitude length? Vector magnitude. I thought that was just the length of a vector, which is the length of the vector. Using the distance formula. Okay, yeah, that's correct. I'm correct. So yeah, I want this in a number. So this is like what, 20 units or something? I don't know, 20 pixels. So I wanted, and then yeah, if this was the direction vector, and then we have a normal this way, then we reflect it. So now I want this distance with this direction vector, with this reflected velocity, and then give me what that move would have looked like. Now that I'm thinking about that, that's not necessarily accurate, because leftover would be, oh, I need more math, right? I would need, oh no, I'm getting the end position. Okay, yeah, so that's right. That's right. Okay, hold on. Do physics too. I guess it was on the screen. But yeah, so we're calculating the end point of where we would have been subtracted. Okay, so it's not okay, so it's actually like this distance, right? We're calculating the end point, subtract the leftover, and we want this distance. And so now, yeah, I think that is correct. So now we're like, okay, so we're moving And we've obviously moved inside the rectangle. So now we're taking the intersection point, calculating how much we have left to move. And with the intersection point and all the other information that we've done, we found the normal, and we can reflect their ball velocity to bounce. I air quoted off of that normal, or off of that line, for the rectangle. And then we're going to move the ball's position to that intersect point plus, double confirming that I plussed, or that I'm doing addition, plus the magnitude leftover amount that we went inside the rectangle along that reflected vector, which is the leftover times ball velocity. So all this other stuff was incorrect. I don't know how or why that worked. That probably was a lot of the problem with the ball getting stuck inside, that it just didn't move it enough, or in the correct direction. That might explain why some sides were very, very bad, and it didn't push it out enough. So hopefully this fixed it. So I did that big explanation without testing this code. This could actually very well be broken, but let's hope it's not. Okay. Oh, that was weird. It was fine. I wonder if we had multiple collisions there. No, that was very weird. I wonder... Oh, that was weird too. Yeah, that was also weird. Oh. That didn't seem incorrect. That seemed incorrect. Maybe I'm doing the magnitude. Well, that shouldn't matter, right? F left over. We can't get negative, can we? Oh, you know what I think? I think I want the... What? Oh, do we get in conditions where we can't? Uh-oh, that's not good. Oh, do we get into a condition where nothing hit? Uh-oh. The other thing too is that I don't want this intersect point. I want that contact point. Intersect point's not what we want. That's probably why we're jumping around. Jump, jump, jump around. Yeah, even use it here. Yeah, so we just want the contact point. I don't know what I was thinking here. But let's see. And whoops. Oh shit. Shift delete or shift D. Okay, and then we can just have an empty one. I don't know if that'll fuck anything else up later on down the road, but that's fine. So yeah, that intersect point, we don't want this intersect point, we want contact point. Okay. That looks fine. That looked okay. I can just step through. The problem with that is that it's not moving enough. Oh. Because I don't think I'm taking the ball radius into account. Fuck. I think we need to do leftover magnitude plus half of the ball radius. We'll just do fat ball radius right now. Yeah, okay, that's better. I think that's the correct like angles and everything. I think it just happens too fast because we're doing like a big, yeah, I think we're doing like a big movement. And I don't think we're supposed to be doing that big of a movement. Okay. Yeah, now we can do this at the end and times 0.5. Yeah. No, it's radius. I think we want, yeah, no, I think we just want radius. That makes sense. Do we want to add radius? I think so. What are we getting for these? 18, 16, 18, 19. And then that's reflected, right? I don't know what I'm looking at. Man, I think to do this, like to make this look good, I think what I want to do is instead move this, just like find this, right? But then maybe a little back, right? Like just before it touches. And then reflect the vector, and then next simulation it'll move that way instead of going further in. Because right now we're going from here and then we're just jumping over here, and it kind of looks weird, especially at great angles. Because at smaller angles where it like goes up and down or even like slightly over, and then it goes like slightly that way, right? It still looks fine because like it doesn't appear to be moving that much. But if it's like at extreme angles like that, isn't like you're moving from here, you should be like here and then like here and then like here, but now you're just moving like here and then you're just moving like over like here, and it seems like a shift. So I think to do this correctly, I think I want to still use that same formula, but I think I want to do the magnitude of the ball position raw, which I guess I don't need those anymore. Right, so that's going to be the distance to get the center to the intersection point that we have. And I think I want to back off like radius. Right, and I think we're just going to be a little cheesy. I'm just going to multiply that by like that. That's to just ensure that we're not like stuck in this, in the line, right? We're just like, we're moving. So we're moving from the ball position before that we moved this frame to the intersection point, and then we're backing up, and that's the center of the ball, and then we're backing up ball radius plus a little bit more. And the next frame, so that's going to look like we hit that frame, and the next frame, the ball velocity. So we've already changed the ball velocity, so like so we're going to render that, and the next frame we're going to calculate it going on the ball velocity. So I think that will look correct. Fuck. Ball po indeed. Dang it, that's what I didn't want to happen. I want this to be minus. I still want that to be plus. Is leftover just ball position now? No. What am I trying to do here? So I don't want this. Oh, I want this. I want this before we reflect, I think. And I think we want to go negative velocity. Right? Oh, what was leftover in that case? Okay, negative. So that was bad. We don't want negative leftover. Okay, so that was incorrect. So we want this. Does that just work? I don't think this just works. He says, okay, yeah, so it's still doing the shit because we're still going along the axis, right? So we calculated the correct, what was magnitude? That's a lot of magnitude. 25. I think I just want to abs this. I think it was correct because I don't want to move the center radius width inside the thing. I want to not do that. Wait, what is ball position at this point? Uh-oh. Have I been... Oh, I think that's what I was supposed to do. Okay, hold on. No, okay, so I did that. Okay, so yeah, that's fine. That's fine. Doing it right before we pass it in. Okay, so this is the ball position at the start of the frame before we moved it. After we've detected a collision, we roll it back. And then now we're trying to figure out what this distance is, move this ball to it, less the radius. Well, that's negative. That shouldn't be negative though, right? I either want the abs of this or maybe we just don't move that much in a frame. If we only move like 5. Or whatever that is. Well, let's go up here. So yeah, this is... And yeah, I don't think leftover should be that big. Well, what is radius? Radius is 10. He's a thick boy. Can that ever happen? Oh man, we might have to stream later tonight. I want to solve this. I might need to take a break and make dinner. How is it ever negative? Wait, what? Hold on. BR burr. Times. Oh. Yeah, okay, that makes sense. Aha! 0, 1. And then we're gonna subtract that. And this shouldn't be negative at all. Why? Why is it negative? What? That doesn't make any sense. Why is leftover negative? Oh, well that's okay. Hold on, we're gonna do the first frame. Leftovers. Okay, yeah, no, that's fine. Magnitude, BR. Yeah. Okay, that's cool. Okay, so that's correct. That's what we want. We're just doing the incorrect thing at the ball pose. Okay, so here, now we want to calculate that before we reflect because we want to move yeah, I think we just want that. We want to add that. Does that not look smooth? See, so it did that thing, so maybe I didn't move it that well. Maybe the collision is a little off because it did look like it was inside. Like the last frame, it was like inside. The tippy top might have been just barely not touching. Maybe my math's off a little bit and it was indeed touching. So something that would help with that, I think it would be stepping, because right now I'm just moving the full amount, and I think you can do this through normal or differential equations, where instead of stepping, you kind of just figure out the exact contact point. I don't know any of that, so I think a lot of the industry does steps where they'll take the movement amount and they'll just do like, so here we've already detected that we have a collision, so they'd step a little bit more to get a more accurate contact point and then do operations based off of that. You can also do an entire simulation in a step. But I mean, like, we're on circles and cubes, or circles and rectangles, so I don't really care too much about what it is. I just want the thickness to be there. So I think this is fine. Like I said, the walls can stay the same. Don't really care too much about that. I think I'm gonna keep that debug in for a while. We're gonna get the player moved over. Maybe I can just finish this real quick. I wanna see a side. Yeah, I think that's... Cool. Yeah, so I think that's pretty good. Good. Banana. Okay, now we can move the player to that. Oh, I guess I didn't even test the actual thing. How do I? Oh, so close. Oh, that was so close too. Go back. Okay. I think it probably would have entered in between the things, like before. I think that's a good enough. Oh, that was a lot. Shit. Not quite. Oh, shit. That was pretty close. I don't know. I think we should just trust this. I think it's better. Okay, let's fix the walls, I guess. That's fine. And it's a screen width minus a ball. Yes. Oh, actually, just kidding. We don't want to do it that way. Oh, it's probably doing the wrong calculations. Shit. Whoops. Do that. Go back to where it was. We're gonna do. Oops, shit. Ah, fuck. Bounce. Physics 2. Ball pose. Rainball. Velocity. Intersection. 1. Normal. Then we can just probably early out. Return those things. Otherwise, don't do anything. And then could probably call this wall physics. Probably didn't want to actually do that right now. Physics. Oops, shit. Fuck. Oh, wait, whoa, wait. Oh, because that's not colliding, so we don't get an intersection, so we don't do anything. Uh-oh. Uh-oh. Okay, Yeah, so we're just gonna go back to how it was. Oh, probably because it goes in there. Ah, man. Why? Do I just... Yeah, that looks really bad. Do I just... Do I scale PV frame by ball radius? Is that the solution here? I mean, I won't say solution, but maybe that's the hack here. That was way too much. Where is it going? Oh, it goes back. No. What? Why didn't it reflect? Oh. The problem is, okay. We're in a function that does specific wall physics. So we're just gonna make ball end. Fuck, I need to stand. I thought I stood already. Oh wow, it's late. Oh man, I don't want to end here. We were on a roll. Yeah, no, I need to take a walk because I've been sitting for too long and I need to make dinner. Shoot. Well, I don't know. Maybe I'll stream either later tonight or tomorrow because I really want to finish this. So the problem though is that, I guess I can kind of describe that, is that we have this thin wall and we are detecting if the center of the ball radius is less than, the center of the ball radius position is like less than that, because then that means that, try to draw this, something like that. Obviously that's terrible. Something like that. Something like that, actually. That's decent. So we're contacting with the wall, but so with the old algorithm, we took the center, which I guess is more here. And we would wait for the center to cross the movement of this ball, wherever the vector is. We'll see it's this way. We'll wait for that line to cross, and that's how we do it. So then when we move the invisible line here, we're not checking the invisible line. He says out loud, realizing that that's what we could be doing. We could probably check this invisible line now that I think about it. To see it, like what to do all the movement bounce stuff off of this line as opposed to this line. No, because everything else that's written does this correctly. So what we need to do is we need to just for the sake of checking, we need to extend this by a lot. So like ball end basically just needs to be increased by an order of magnitude. We can just do 3, right? Because if we're only doing this for the wall physics and we only want to ensure, because we already know that we have a collision. We just need the information to like fucking deal with it, right? So hopefully with all this will be fine. Now, is this going to give us an actual contact information? Are we going to have that teleporting ball like we did with when I had it wrong on the cubes, on the blocks? That might be very real, but hopefully why does this do nothing? What the fuck? Oh. Well, because I'm dumb, that's why. Ball frame, oh, BB frame. Times 3. Ah, there we go. That didn't look bad. Oh, I can't make there in time. Oh. Cool, okay, so we fucking just fixed it. Lick my butthole. Ah, oh, dang it, I spoke too soon. Okay, oh, that was wrong. I went a little too far. Oops. Okay, so we did not get any of this done, but we are very close to refactoring our physics code. What we're gonna do is I kind of just gave up. I don't know why I'm doing this anymore. Again, I'm stuck on this line stuff. I didn't want to break. I don't want to fix. Yeah, I think it was the don't fix what isn't broken mentality, where I was just like, oh yeah, this works, and then I try to add something and it just absolutely does not work, which is just not good engineering. So I'm going to scrap this whole like line stuff, and then so we're going to have a screen. So this is our screen. I'm going to draw a little more stuff so you guys understand that it's a screen and not, oh shit, This is a beautiful canvas. Okay, yeah, right. You guys get it. We have other shit here, right? Cool. And then we have a ball. So we're gonna have invisible rectangles that are just gonna be over here, and they're gonna be, I don't know, they can be as thick as we want, right? We're just gonna make these outside of the screen. So if obviously they're gonna be the same size and uniform. I just suck at drawing, but we're just gonna use this, and at the end, oh, actually we're not gonna use that bottom one. So we're gonna keep this bottom one to just see if the center goes out of the screen, then like that's just game over. We're not going to do any bounce physics or anything off that. That's just game over. GGU lost, right? And that's fine. But for these, we're just going to put these into a nice little collection outside of our blocks and outside of our player. And then we're just going to do normal physics based off of them. We're going to play the sound effects, but there's no score or anything. This will be way easier. I think I'm going to try to, after dinner, maybe if I have time, which it sounds like I might, I'm gonna try and do this, and then we're gonna finish the blocks later tonight, maybe in like 2 or 3 hours. Yeah, maybe. And then, yeah, after that, then we can add the player velocity and then clamping the player to here and here. I think that's it. I think we're done. But I do kind of want to add the multiplier. To your score. So I'm going to write that down. Multiplier score. And then, well, first and foremost, we're going to finish physics rewrite. Okay, and I'm also going to commit this. Div. Yeah, we did so much. Added scores, sound effects, and almost fixed physics. Commit a fuck. Add data. Git commit a. Alrighty. Let's see. Added sounds and music. Added score. Rearrange blocks. In the middle of a physics rewrite. Looking good. Need to get balls in player converted. Then add player physics. So just a reminder for that is that, and I'll post this to GitHub eventually, maybe tomorrow. The player velocity stuff is basically where instead of just moving the raw pixels, we're going to like do a physics step with the player, and then in that physics step, I think we're just going to check, basically do another ball collision. So we're going to have two collision checks with the ball and the player. One when the player moves. If the player moves, then we're going to do bounce physics off of wherever the player moved to. I'm not sure exactly how to do that. Probably just reuse the same system. I don't know if it'll really matter. The only tricky part is that the ball hasn't moved yet, right? So we can't really do the same logic of like, oh, the ball wants to move there over here. So we might have to change a little bit. But now that I have, now that these are kind of more separated, we can kind of get the separated logic. I kind of accidentally did this. I was trying to like stuff circle versus rectangle all into one thing, but this basically just says if there's a contact, so we should be able to use that no matter if the ball's moving or if the player's moving. And then if we did get a contact point, or did collide. Then I think we can find the face normal. So this will just be ball position and then the player rect, which we might have to construct. I don't know if I want to store a player rect somewhere or if we just construct one for all player physics, which we probably have to do. Maybe we store the player. I don't know. Figure it out later. And then so that's the tricky part. After we find the face normal, we want to do the, oh shit. Oh no. Oh no. Whoops. Oh no. Because there was a 2 at the end of that, that just worked. Okay. Well, that's what I get for naming something do bounce physics 2. So yeah, we might have to manipulate the data here a little bit, because everything's kind of written for the ball moving. So maybe we need new functions that just like do the bounce physics, but like do them differently. I don't know, because what I'm afraid of is that the player can move like full ass like inside of the ball, right? Like the movement is just huge and the ball's just going to be like inside, right? And then so that we can't really use its like last like velocity and like center to center logic to like see which normal it found. That's the concern. Maybe the player doesn't move as fast as I'm thinking. But yeah, so at this point right now where we do the bounce physics, then we'll be able to, I'll need to figure something out of like, oh, well, we can't really do that because the player moved into the ball, but hopefully I'll figure that out tonight. Tonight though, the main goal is to, yeah, like I said, just get this converted and then finish the logic up here and then get the player converted, and then we can worry about the player velocity, and this shouldn't be too bad, and I don't know how terrible this would be. Probably not terrible. But yeah, that's it for today. Well, for right now, hopefully I'll have time later tonight, like I said, and we'll finish up all of the stuffs. But yeah, I'm gonna take a break. I'm gonna end the stream, gonna eat dinner. Thanks for tuning in. Later.